In 1977, Voyager 1 left Earth carrying a golden record, and decades later it pierced a boundary no human had ever crossed, the edge of the sun's influence. But what if that wasn't the true edge? What if there's a hidden wall, 1.5 light-years away, that quietly defines where our solar system ends and interstellar space begins? This isn't a sci-fi twist, it's a scientific mystery. And today, we're diving into a frontier so distant, even light takes over a year to reach it. Ready to travel beyond the invisible? The mysterious boundary of our solar system. You know the planets, the asteroid belt, and maybe even the Kuiper belt. But what if I told you that everything you've learned is just the beginning? Our solar system doesn't end with Neptune or even Pluto. It stretches into a vast, invisible region that defies our traditional understanding of space, and it's more mysterious than any alien planet. Scientists believe that somewhere out there, nearly 1.5 light-years from the sun, lies an invisible frontier. This isn't a wall you can touch or see, but rather a conceptual border that marks the end of our sun's dominant influence. Beyond this limit, other stars begin to tug more strongly at anything caught in space's icy grip. But why does this boundary matter? Because it challenges the very definition of where home ends and the interstellar unknown begins. Astronomers refer to this edge as the outermost limit of the sun's gravity well. Everything inside is technically part of our solar family: comets, particles, even icy bodies from the Oort Cloud. Everything beyond? That's galactic wilderness. And while we haven't physically reached that far yet, we're inching closer with every deep space mission. Understanding this invisible wall helps scientists trace the origins of long-period comets, map the sun's protective bubble, and study how our solar system interacts with the Milky Way. It's not science fiction, it's cosmic reality, unfolding at the edge of everything we know. The Heliosphere. Every second, our sun blasts out a stream of charged particles at supersonic speeds. These solar winds race through space, forming an invisible bubble that wraps around all the planets. And it's this shield that makes life possible here on Earth. This protective shell is called the Heliosphere, and it acts like a giant force field. It's not a sci-fi invention, it's real, massive, and constantly in motion. Inside the Heliosphere, the sun reigns supreme. Outside it, interstellar space full of radiation and unknown particles, the boundary where the solar wind gives way to that galactic pressure, that's the heliopause, and it's one of the most important markers in all of astronomy. The heliosphere stretches far beyond the orbits of our known planets, past Pluto, past the Kuiper belt, into the deep void. It ends where the solar wind slows down and the pressure from the interstellar medium pushes back. Think of it like the skin of a balloon, but constantly fluctuating in shape. What's fascinating is that this bubble isn't smooth. It's rippled, warped by magnetic fields and solar cycles. In 2012, NASA's Voyager 1 pierced through this invisible line, confirming its entry into interstellar space. That moment marked the first time humanity truly stepped outside the sun's protective cocoon. The data from that journey is still being analyzed, revealing just how complex and dynamic our bubble of safety really is. Voyager 1's journey beyond. It started as just a machine launched in 1977, but today, Voyager 1 is humanity's furthest messenger, sailing alone through the abyss beyond our solar system. When it crossed the heliopause in August 2012, we didn't just gather data, we rewrote history. For the first time ever, a human-made object left the sun's protective bubble and entered interstellar space. But what exactly did Voyager 1 find beyond the border? It wasn't just darkness, it was a storm of galactic cosmic rays, high-energy particles that have been wandering the Milky Way for millions of years, now crashing against the sensors of our little probe. Before the crossing, Voyager 1 felt strong solar winds and a consistent stream of charged particles. But after the heliopause, those signals suddenly dropped, replaced by an entirely different energy pattern, proving definitively it had broken free of the sun's grip. The transition wasn't dramatic in visuals, but in science it was monumental. Voyager 1 continues to relay signals back to Earth, whispers from a place no spacecraft has ever been. And here's the mind-bending part: even though it's in interstellar space, it hasn't left the solar system entirely. Why? Because the gravitational boundary, our solar system's true edge, extends even farther, possibly up to 1.5 light-years. Voyager's journey tells us that the space beyond our sun isn't empty, it's alive with forces we're just beginning to understand. The Oort Cloud. Far beyond the planets, past the Kuiper belt and the heliopause, lies a realm so remote and mysterious that no spacecraft has ever seen it, and yet its presence is one of the most compelling ideas in astronomy. It's called the Oort Cloud, and it's believed to form a giant spherical shell around our solar system, stretching out to 100,000 astronomical units. That's almost 1.5 light-years. But this isn't science fiction. It's the theoretical birthplace of the longest-traveling comets, those icy wanderers that swing by once every few thousand years. Every time you see a long-period comet blazing across the night sky, there's a good chance it was launched from the outer reaches of this frozen halo. The Oort Cloud isn't like a dense ring or belt, it's more like a swarm, a diffuse cloud of icy bodies left over from the birth of the solar system. Too far to see directly, too scattered to visit, yet its effects are undeniable. Something out there hurls ancient comets inward, disrupting their frozen slumber and sending them diving toward the sun. These cosmic visitors carry secrets billions of years old, and they remind us that the edge of the solar system is far more dynamic than a simple boundary line. If we could reach the Oort Cloud, we might uncover the final remnants of the solar system's creation. Until then, it remains our invisible, icy frontier, quiet, distant, and full of cosmic possibility. The 1.5 light-year wall. The 1.5 light-year wall. There's no glowing gate or physical barrier, but 1.5 light-years from the sun, something monumental changes. At that distance, the sun's gravitational grip finally fades. That invisible limit? Astronomers call it the outer edge of the Oort Cloud, and it acts like a cosmic border checkpoint. On one side, the sun's gravity still has influence, on the other it's the domain of the galaxy. This boundary is what scientists often refer to as the edge of the solar system, not because something stops there, but because that's where other stars start to tug harder than our own. This invisible wall isn't made of matter, it's defined by forces, gravitation, radiation, and the subtle ballet of interstellar interactions. Think of it as the final frontier of ownership. The sun's reach, though still faint, technically ends around this zone. Past that, you're not just leaving the solar system. You're entering the Milky Way's open field. What's wild is that objects in the Oort Cloud, still part of our solar system, are farther away than most stars in the galaxy appear in our sky. The sheer scale is hard to comprehend, but understanding this wall helps scientists trace the journey of comets, predict space weather, and even estimate how safe we are from external cosmic threats. We may never see this boundary with our eyes, but it's one of the most important lines we've ever tried to draw. Galactic tides and stellar encounters. You're not just floating calmly at the edge of the solar system. Out there, beyond the 1.5 light-year mark, the universe gets restless. The Oort Cloud doesn't just sit quietly, it's constantly nudged and stirred by forces beyond our control. Every few million years, a rogue star passes close by, or the gravitational tides of the Milky Way pull and stretch the cloud's fragile balance. These forces can jostle comets from their icy slumber, sending them tumbling toward the inner solar system, sometimes becoming brilliant spectacles in the sky, and sometimes becoming threats. These galactic tides are real. They're like invisible ocean waves created by the galaxy's mass, shifting the orbits of distant objects in the Oort Cloud. Even small shifts can change the trajectory of a comet enough to send it plunging toward Earth. The sun, as mighty as it seems, can't control these movements alone. It's constantly being challenged by the collective gravity of the galaxy. Some scientists even theorize that nearby supernovae or passing brown dwarfs may have triggered ancient comet showers, linked to mass extinction events on Earth. It's not just academic curiosity. Understanding these interactions helps us prepare for what might come. Because out there, space is not silent. It whispers with motion, pressure, and the potential for cosmic surprise. The significance of understanding our cosmic boundary. We live on a rock orbiting a star, in a bubble of solar influence, surrounded by an invisible cloud of icy debris, and beyond all that, a wall we may never touch. But knowing it's there changes everything. The more we learn about the boundaries of our solar system, the more we realize how vulnerable and extraordinary our place in the universe is. Understanding where our sun's influence ends allows scientists to map how our solar system interacts with the rest of the Milky Way. It's not just about defining a border, it's about recognizing how we are connected to a much larger cosmic dance. This knowledge also drives real-world science. The data from Voyager, the models of the Heliosphere, and our understanding of the Oort Cloud help protect satellites, forecast cosmic radiation risks, and guide future missions. One day, we might send a spacecraft deep enough to brush against that gravitational wall, and maybe beyond. But even now, with only theory and inference, we are sketching the edges of our cosmic home. It's a reminder that Earth isn't the center of anything. It's just a small chapter in a story far bigger than we can fully grasp, and that invisible 1.5 light-year wall, it might be the most profound boundary we've never seen. The edge of our solar system isn't marked by a planet or a line. It's defined by mystery, gravity, and time. As science inches closer to the great beyond, we're reminded that the universe is far vaster than we ever imagined. If today's journey sparked your curiosity, just wait until you see what's next. From the depths of black holes to the birth of galaxies, we explore it all right here. Thanks for joining us on this cosmic ride. And if you love discovering the secrets of the universe, don't forget to like, subscribe, and hit the bell icon for more adventures.